Okay, well, this is a question from 2022, paper 1 1, and it's a winter series, question 23. This is about transverse wave traveling along a rope. The diagram shows the rope at time t0. The wave is traveling from left to right. The period of the wave is t, capital T. Now, one particle of the rope is labeled x. You can see in the diagram, which graph shows the variation with time of the displacement of particle x between t0 and till t to 20 to twice of t, sorry. Now if you look at the position of the x right now, the position of the x is actually on a mean line, so it means the currently displacement of the x at time t0 is 0. So it means if you look at the options, option C, time t0 the displacement is not 0. Option D, time t0 displacement is not 0. So C and D are both the wrong choices, right? Now its only thing left is A and B. Now if you look at graph A and B closely, the A is exactly looks like the shape of the graph, right? The real wave, the option A, while the option B is a bit kind of sorry for that, in opposite direction. Now we are looking for how the x travels, and remember that it's a transverse wave. The particle always try to vibrate perpendicular to the direction of the travel of the wave. Now if imagine this wave is traveling towards right, so it's a very simple जुगाड़, like a method, a slang method कि हम कैसे find out करेंगे x. Since the wave travel from left to right, you start thinking exactly in the opposite direction how the particle will vibrate. If this wave travels this way, the particle will start shifting like in this position over here in a reverse direction. So it means that particle x will start moving from time t0 in a downward direction of displacement. So downward direction of displacement, it since B the only option, that's why it is B. And try to remember this method. This will be applied every time when we have a progressive wave and we need to locate how the particle displays with respect to time. ठीक है. If the wave travels from left to right, start thinking for the displacement of particle from left to right to left. Okay, thank you very much.